Okay, for area of triangle, trapezoids, and kites, the terms that you're going to need to know will be base and height, which when we talked about parallelograms was interchangeable with length and width, but for these shapes we'll only be using B and H for base and height. Base and height must make a 90-degree angle. They're perpendicular. Remember, this is the symbol for perpendicular. Okay, you may also see D, which stands for diagonal. You'll see that when we talk about kites. Triangles use the formula 1/2 times base times height, or you may sometimes see it written as base times height divided by 2. That's the same thing. Most often you will probably see it written as the fraction 1/2 rather than divided by 2. So I'm going to use this form here. For our first example, we're given a right triangle. So our right angle is already drawn. Same holds true that's true for parallelograms. Base and height must make a 90-degree angle. So 8 and 3 must be the base and height because they make the 90-degree angle. They're perpendicular. So I'll say 1/2 times my base times my height. It does not matter which order you multiply this out in, again, because when you multiply you'll get the same answer. So you end up with an area of 12. This was measured in meters. Area is meters squared. Okay, in example 2, there is no right angle in your triangle, okay, but you do know this is isosceles because of these tick marks. When you draw an altitude or a height down in an isosceles triangle, okay, that comes to the center of your base. Okay, of course, an altitude or a height is going to make a 90-degree angle. That's what the definition tells us. But since it's isosceles, it also cuts this in half. So if this entire length is 16, this side would be 8. Okay, so now to find area, our base of the whole triangle is 16, but we don't know the height. We are going to use this right triangle that we created to find the height. And again, like when we did the parallelogram, we've created a right triangle where we know 2 sides and need to find a third. So to find this missing height, I do Pythagorean theorem. So off to the side here, I'm going to plug in to Pythagorean theorem. Remember, across from the 90-degree angle, that is your C. So 18 is C. 8 is one of our known sides. B is what we're looking for. B. 18 squared is 324. You're going to subtract 64 over. Okay, and that leaves you with B squared is 260. And the same thing we did last time, that last step, you get rid of the squared by taking the square root. The square root of 260 is approximately, when you see these, it looks like an equal but squiggle, that's approximately, because we're going to be rounding a decimal, approximately 16.12. Now we can plug that in for our height. So we have 1/2 times 16 times 16.12, which gives us approximately 128.96. The units were feet, so that would be feet squared. Next up is the trapezoid. Our trapezoids use the formula 1/2 times base 1 plus base 2. Notice that's in parentheses, so we have to do that first, times the height. Okay, again, instead of 1/2, you may see it as divided by 2. Okay, but you still have to do the base 1 plus base 2 first, and then you can divide by 2 and multiply by your height. So in this first example, we have the dotted line drawn from base to base. Okay, remember the 2 parallel sides are your bases. So this would be base 1 and base 2. Okay, remember, base and height must make that 90-degree angle. So this piece here would be the height. Okay, we don't know the height. We are told that this is isosceles because of these tick marks. So this side must also be 4. And we know 4 and 2 in a right triangle. That would be our C in Pythagorean theorem. So we have 2 squared plus b squared equals 4 squared. You subtract the 4 over, and the square root of 12 is approximately 3.46. So in our formula, this is approximately 3.46. So 1/2. Now my two bases were 7. The full length of this base was not given, but since this is isosceles, you can see that this height would be the same here. Those would be parallel, and it would make this piece equal to this piece. So this would also be 2, and these across from each other, we just created a rectangle. So this would be 7. So then you add up that entire length, 7, 2, and 2, 11. And then the height we found to be approximately 3.46. Okay, so it does matter on this that you do this in the correct order. You could plug this all in at one time into a graphing calculator. Pull one up here. Oop, clear that out. So we would say 1/2, and I'm just going to use 0.5, and then in parentheses we had 7 and 11, and then it was multiplied by 3.46. So 31.14 approximately, because we had rounded. I already forgot what that said. 31.14. Your units were in inches, so that would be inches squared. Okay? If you did this individually and added that first and then took half and then multiplied, that would work as well. Just make sure you use the correct order of operations. In example 2, this is a right trapezoid. There is a right angle already in the trapezoid, so I don't have to do Pythagorean theorem to find the height. It's already given. So this one is going to be a bit simpler. 1/2. Okay, the bases are the two that are parallel, so 9 and 13.5. And then it's multiplied by the height, which in this case is 7. So 0.5 times, in parentheses, 9 plus 13.5, close your parentheses, and then times 7. And you get approximately 78.75. These units were centimeters, so it is centimeters squared. Okay, so now we're on to kites, and the formula for area of a kite is 1/2 d1 times d2, and these stand for diagonal. So you have two diagonals, and these examples you can see they're drawn cross, okay? And remember, from properties of kites, diagonals intersect at a 90-degree angle, okay? And again, just like triangles, you could also write this instead of 1/2 times, you could do diagonal 1 times diagonal 2 divided by 2. Okay, so in this first example, we're going to take the longest diagonal here. We know that this is 3.5 and 10. So that means that's a total length of 13.5. So looking for area, we can plug that in for diagonal 1. 13.5. We need diagonal 2. Okay, we know that this is 2, but this is not labeled. So this makes you have to remember your properties of kites. And then the properties of kites, you should know that the diagonal connecting the two non-vertex angles, okay, this is bisected. So this side is equal to this side. So this would also be 2. So that entire length would be 4. So then you would say 1/2 times 13.5 times 4, and you would get 27. And that is centimeters. So area is centimeters squared, or squared centimeters. Okay? In the second example, same formula. Okay, but we're not given any of the lengths of this longer diagonal. We're going to have to do some work to find them. We are given half of this one is 4, so this would also be 4, so that's 8. So we know one of them is 8. We need to find the second. Now we know that this 90-degree angle in the center is creating these right triangles. So then you can take the fact that you know 4 is one of the legs and 5, that's across from the 90, so that's your hypotenuse, okay, is, so we know A and C. So we can find B using Pythagorean theorem. If you have your triples memorized, it saves you some work here, and you realize, well, this is then a 3, 4, 5. So this piece is 3, but we still need this piece. So again, we're looking at it as a right triangle, and we know 4, okay, that's one of the legs, we'll call A, and then across from the 90, this would be my C, so I need to find this B. Okay, so 4 is a leg, we don't know B, and 12 is our C. You move your 16 by subtraction. So you're left with B squared equals 144 minus 16, which is 128. And to get rid of the squared, the opposite function is square root. So B is 11.31 approximately. Now we need the entire diagonal. So we have 3 and 11.31. So if you add those together, you will get your full diagonal. Okay, that plugs in here. So then you have 1/2 times 8 times 14.31 for a total area of 57.24, and again this one is in meters, so area is meters squared, or squared meters. All right.